Right, so we're going to go through arc length. How do you find arc length? First, we're going to work in degrees. So some of the problems that you see in terms of degrees would be of this type, where they give you what's the distance between two cities. So you're going to assume that these are on the same side of the equator because they're both north. So if I have one city here, which would be Dallas, is 32 degrees 50 minutes north. And then I have Lincoln, which is 40 degrees 50 minutes north. I need to determine what this angle is in between these two cities in order to use that equation. Theta over 360 degrees is S over 2 pi r. The question is, they want to know what's the distance between the two cities, so we're looking for S. They didn't give this to us in this problem, but I would give it to you on your test. Use the radius of the Earth. We'll use 3,964 miles. So I know the arc. So I still need to come up with this theta. So if I go to my calculator, I can find the distance between these two cities. Of this. By subtracting these two angles, so 40. You can do second and apps key, which will have the degree, and 50 second, the apps key number 2 is minutes, and subtract the other angle, 32 degrees, and 50 minutes. Okay, and you just write your answer. Now this one worked out evenly and pretty easy, but they're not all that nice. So we can get that angle was 8 degrees between these two. And then we can fill in what we know. So it's 8 degrees divided by 360. S is the distance between the cities. That's what I want. And then 2 pi, the radius was 3,964 miles. So you can either reduce or you can cross multiply right off the bat, whichever you prefer. The degrees cancel out. So I'll have 360 times S equals 8 times 2 pi times 3964. And then if I multiply this, I'm going to do this with the regular calculator here. So 8 times 2 pi times 3964. So that's going to give me 199,252,3725. And then just divide by 360. And we'll get the distance between those cities is 553.4788, so 789, and that's in miles. So here's one for you to try. If you look at okay, I missed a page. So here's one for you to try. So if you hit pause on the video, you can go through and work this out and then come up with your answer here. I'm going to work it out quickly and write this down here. So. You can use pi is 3964, or the radius is 3964 again. Right, so for this one, if I did this correctly here, I have my S is going to be 472.763. Plugging that one in. And then let's look at one more type of problem here. So this is kind of creepy. So you have the eyeball, and they want to know what the radius from the center of like your eyeball out to the cornea. So this is the center on out there, and they're saying the length of the cornea is really like your S, the arc length. So they gave us the length for the cornea. The length of the arc is 11.5. The angle is 182 degrees. I wrote degrees out because I didn't have that symbol there. So If you use your formula theta over 360, S over 2 pi r, since I'm looking for radius, I can fill in the values that I know. So 118.2 degrees over 360 degrees. The length of the arc is what I am, I'm given that. It's 11.5 millimeters. And then I'm looking for this radius. And if you cross multiply, we'll have 118.2 times 2 pi. So you can take that into your calculator. So 118.2 times 2 times 2 pi. And you can hit enter. So cross multiplying the one way, 742.67250. That's going to disappear in a second here. Oh, I forgot it. All right. 67250. Alrighty. And then if you cross multiply the other way, we've got 360 times 11.5. 4140. And so when I cross multiply this way, I forgot my r. So this thing is times r. And then if we divide by that coefficient, it's 742.67250. We get a radius of, let's see. So it was 4140 divided by that radius answer. You get 5.574. That was measured in millimeters. Right, and then there's one here for you to try that's almost the same. Okay, if you look at this one, now you're working in the other direction here. So theta over 360 is S over 2 pi r. This time you're given S and you're given r. Now you're looking for the angle in degrees and then round your final answer to 3 decimal places. So if you pause the video, then you can work this problem out and then hit play again and you can see if you did it correctly. I'm going to start solving it right now, so make sure you hit pause. So theta we don't know, so we've gotten the problem over 360. The S was 12.1, and then 2 pi r is 5.26. That was also measured in millimeters. So the millimeters cancel out. If you cross multiply them, we're going to have 2 pi times 5.26. I'm going to do it in my regular calculator here. So cross multiplying, I have 33.04955 times theta, and then 360 times 12.1. It's going to give me 4356, and this still has a unit with it. It's still in degrees, so that's how my degrees ends up in the answer. And then to get theta by itself, I need to divide that by 33.04955, which gives me an angle of 131.802 degrees. And then let's see if we have another one on here. I think that's the only one I did. Yeah. All right, and then we'll do some arc length problems in the next video.